I'm Zachary, and this is Lab 2, Charge Tape Revisited. Introduction. The purpose of this lab was to model the Lab 1 experiment of placing two charged tapes next to each other, B on top and A on the bottom, and see what the charge on each tape is due to how far B was lifted above A, seen in this diagram here. The physics principles we used was the electric field equation, the constant charge on the bottom tape times the distance between the tapes squared times the direction between the tapes, which was just y hat. Then we used the electric force equation, which was the electric field found here, times the charge of the top tape. Then we used force of gravity, which is mass times acceleration of gravity. The results, this is a brief overview of the results. This is the top tape right here. This is the bottom tape right here. Electric field vectors, electric force vector, and electric force of gravity vector. The initial conditions / assumptions. The assumption we made was to simplify the tape into 10-point charges. In reality, it's millions of point charges or more. The system was the top tape, the surroundings was the bottom tape, and the Earth. Initial conditions, mass was 1.45 times 10 to the negative 4th kilograms. Charges were 2.38 times 10 to the negative 6 coulombs. Force, the acceleration of gravity is 9.81. K constant was 9 times 10 to the 9th. The distance between the two tapes was 6 centimeters in the y hat direction, and the length of the tape was 1.45 meters, 0.145. Details of the experiment. This was what we set up in Lab 1. And to code this, we simplified the top tape into 10-point charges as well as the bottom tape. In Lab 1, we charged both tapes, suspended B above A, and see how far B was lifted above A because they were both positive charges. Then we calculated the electric force and the force of gravity, setting that equal to each other, and we calculated the charge. In part 1 of the code, the yellow is our initial conditions, the green is our function for the electric field. In cyan, this was the function for our line charge, setting up the line of charges. And in blue, this is where we called this function to create the line charges. And red is the scales and electric force equations. Part 2 for the code. In yellow, we have the finding the charge on the individual points due to each other point in the bottom tape. And then green, finding the middle position in the top tape. Cyan, defining the arrows and electric force and force of gravity. And then finally printing the results. Results, this is our model shown at the beginning. The green arrows are the net electric field vectors due to each point charge on bottom tape, due to each on each point in the red tape. The white vector is the net electric force on the top tape due to the bottom tape, and the yellow vector is the force of gravity on the top tape. The differences between this model and the real experiment is that the real experiment, the change in the tape wasn't evenly distributed, and there was many more point charges, which introduced some error. The questions. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got, the line charge. The charge we got in the point charge was less than the line model. Why? Because the electric field in the line model wasn't purely in the y-axis. As you can see here, there's some going off to in the x-axis direction, which did not contribute to lifting the tape. So it needed more charge to exert the same amount of force as a single point charge model. This line model is closer to the real value. Thank you.